Hello, welcome back. We're still going over some examples that will help you with the prep work, the preparation work that will get you to, hopefully you'll be able to make some generalizations about finding the zeros of polynomial functions. Okay? Try not to give away too much there. So look at this nasty thing. We want to find the zeros of p of x to the fifth plus 11x to the fourth, subtract 27x cubed, subtract 335x squared plus 350x. That's the kind of problem that you're going to look at and go, nope, I'm out. Just stay with me. It's nowhere near as bad as you think it is. And that's the really cool part about this. Everything you need to know to find the zeros of this, you already know. We're just going to put it all together. The first thing you should notice is this. I'm going to do it by factoring. And I have a GCF. So I have x, 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 and an x here. There's a GCF of x. So that means that I have a 0, x equals, get this, 0. And if I look at it, 0 to the fifth power, 0 to the fourth power, 0 to the third power, 0 to the second power, 0, those are all 0. So everything here just becomes 0 plus or minus 0, which is 0. That one kind of makes sense. So already I've been able to make this go from a pentic power of 5 to a quartic. I've already knocked it down a whole degree. So in factored form, I have x times x to the fourth plus 11x to the third, subtract 27x squared, subtract 335x plus 350. Okay, now this is where I would pull out Desmos and I would see if this is going to cross the x-axis anywhere. But I'm going to hold off on that for a moment because remember, we're trying to teach you different skills. We're going to see if you can pick up this skill. Now, one thing about polynomials like this, and we started off kind of with this one, it's a little bit easier because we don't have a number in front of the x to the fourth power. Okay, I've already got x. Now I'm focusing on this one. I should have said been clear about that. That does not go away. Don't lose it. I'm just now focusing on this. So what I think I'm going to get if I do this correctly is I'm going to have x plus something times x plus something times x plus, actually it's x minus something, but don't worry about that. I'm going to get all these linear binomials, and I might be able to factor it down. The last two problems you saw, I factored it into linear binomials, and then I ended up with a quadratic that I had to use the quadratic formula for. So that might still happen here. Okay? But what if it doesn't? What if I don't get a quadratic? What if I get just linear binomials? So it's going to be x plus something times x plus something times x plus something times x plus something, etc. Okay? That something, or all those somethings, are all going to multiply to give me 350. So the first thing I need to do is I need to kind of factor 350. So 350 is 2 times, let's see, 175, which is 5 times 35, which is 5 times 7. So here are the numbers that I'm going to try when I use synthetic division. I also have to keep in mind that maybe some of these might be negative. So I'm going to try 2, 5, 7. I might have to do 5 twice. Negative 2, negative 5, negative 7. And I also might have some other factor pairs in there. It gets a little bit more complicated, and I'm going to let your pre-calc teacher cover that part. Because if you're really paying attention, you might know that maybe 10 is a factor of 350. So it'd be like 10 times 35. 14 times 25 is a factor of 350. So this one actually has a lot of different factors, but that's okay. I'm just showing you the method. like I said, I'll let your pre-calc teacher get into the nastiness about trying everything. I already know what this one's going to be, so I'm just going to show you the method of it. And then you're probably wondering, yeah, but what if it's okay. It'll be okay, right? So I'm going to start off by trying, let's try 2. So I get this. And remember, I already got x equals 0 here. Now I'm going to use this one. So I got 1, 11, negative 27, negative 335, and positive 350. Synthetic division. Looks nasty, but it's not. I get 1, 2, 13. 2 times 13 is 26. 26 plus negative 27 is negative 1. I get negative 2, which gives me negative 337. Multiply 2 times that. Use a calculator if you need to. And I get negative 674, and it does not look like I'm going to get 0 as a remainder. Negative 324. So guess what? 2 is not a 0. 1 down and a whole bunch to go. All right, so now this is where it becomes a little tricky. You have to try a whole bunch of different ones. So I did 2. Now I can try negative 2. Then I can do 5, then negative 5, then 7, then negative 7, then 10, negative 10, 14, negative 14, etc., until I've got all the factor pairs of 350. Yeah, that'll take a while. That's why synthetic division is nice, because it actually goes kind of quick. What if I try x equals 5? So I'm going to pick this 5 right here. So same thing, negative 27, negative 335. And by the way, I've already seen the end of this one, so this is why I'm picking what I'm picking here. So I get 1, 5, 16, 80, 53. 5 times 53 is 265. 265 plus negative 335 is negative 70. 5 times negative 70 is, check it out, negative 350. That gives my remainder of 0. That means so far my factored form, and I'm trying to solve for 0, so I'm going to set this equal to 0. My factored form is going to be x, that x, times x subtract 5, because remember it's x subtract the 0, times, make sure I get my right place, x cubed plus 16x squared plus 53, sorry to bubble that, x subtract 70. All right, cool. So for my 0 so far, I got x equals 0 and x equals 5. Now I got to work with this one. Okay, so I can try different things. I just need a clean sheet of paper, guys. Sorry for the hold up. I can try different numbers again. So I'll try to put this all together so you can see it. So now I'm going to go for x cubed, 16x squared, 53x, 70. And I'm going to go ahead and try, let's say, I've got to look at my notes, negative 7. And remember, that was one of the factors that I could have had here, right? And again, I'm totally acknowledging that I've done this problem to prepare for making the video, so I already know what's going to work, all right? Synthetic division, I've got 1, 16, 53, and negative 70. Try and keep everything in the same frame. 1, 16, 53, negative 70. Zero, 1, negative 7, 9, negative 63, negative 10, positive 70, 0. So now, what do I have? Let's put it all together. Try to put together for you. In factored form, setting it equals 0, I've got x times x subtract 5. Now I've got x plus 7. This is a quadratic, which is going to be x squared plus 9x subtract 10. And this is actually kind of cool, because That quadratic I can actually factor. What two numbers multiply to give negative 10 but add to give positive 9? Don't lose any of the other factors so far. It's x plus 10 times x subtract 1. These are all linear binomials. I didn't end up with the quadratic that I had to use the quadratic formula for. Okay, now again, I need to acknowledge the fact that I cheated. I really did. I cheated because I knew that 2 was not going to work, but I knew 5 was going to be a 0, and I knew negative 7 was going to be a 0. So remember, I'm just showing you how to do it. You're not going to have anything that's going to be that difficult. And there's also, if you struggle, I want to show you this. Here is Desmos. Now, right now, everything looks, look at that. I mean, that just looks like lines going back and forth, but it's not. I don't even know if I'm going to be able to do this. I'd have to really mess with it. But yeah, I don't know if you can kind of tell, like right here. Look, I'm at 2,550 something. It goes up and then it comes back down, right? This, let's go to home. This graph to the 5th power, remember I said to the 4th power it makes like a W or an M? This one's going to go up, down, and back up. That's what's happening. So this is going up. It's going way far up to like 2,000 something. Comes back down, goes back up, comes back down, goes back up. It's just hard to see. I'd have to like really scrunch the screen down so you can see it. I don't know if I can do that. Nope, it's not going to let me. Yeah, it's going to do the whole thing. All right. I don't usually use Desmos on the iPad, so the pinching and stuff, it's not something I usually do. But check this out. Boom, 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 boom. Now, what are my zeros? Negative 10, negative 7, 0, 1, 5. What have I done so far? Right here, x equals 0. Right here, x equals 5. Right here, x equals negative 7. Right here, x equals negative 10. Right here, x equals 1. And I know I don't have them in the order that Desmos is, but if I go negative 10, negative 7, 0, 1, 5, from smallest to biggest, that's what I got. Negative 10, negative 7, 0, 1, 5. So, even though I'm admitting that I kind of cheated and that I knew that this one was going to be able to be factored, I wanted to show you the process of this. However, please keep in mind, it might be nice to be able to start with Desmos. Okay? Before we go, how many zeros did I get? 1, 2, 3, 4, 5. These all happen to be integers and they are all unique. But I still got 5 zeros. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4. Sorry, I forgot what French was for 5. Dang, I'm going to have to look that up. Okay, anyway. We'll see you in the next video.